So let's continue with this question. Now the question says, how many grams of barium sulfate can be made when 42 grams of this iron sulfate Fe2SO43? Now this space I left it because it won't be enough for me to write this compound effectively. So it's used in a balanced chemical reaction. Now this is the reaction to this question they're talking about. Okay, first question 2, calculate the mass of a different question entirely. Calculate the mass of zinc sulfate produced when SS ZnCO3 is added to 500 cm cube of 0.4 mol per dm cube H2SO4 hydrogen sulfate. Okay, so now let's solve question 3, which had the first question there. Taking this as our equation of reaction. Okay, so now let's go. Let's check how many grams of this of barium sulfate, which is this barium sulfate, can be made when 42 grams of this is used in a balanced chemical reaction. So we are comparing this to this. I'm comparing this to this, so that's what they have in the question. I'm comparing this to this, so let's bring them out. So first of all, let's check if our question is balanced. Okay, so we have barium here is 3, barium here is 3 as well. Sulfur here is 3 plus sulfur here is 3. Yeah, so sulfur in this product in reaction side is 6. So sulfur here is 3, sulfur here is 3 as well. So sulfur is 6 balanced. Then iron is 2 as well. Then oxygen is 4 times 3 will give us 12. So oxygen is 12 here. Then 4 times 3 will give us 12. So oxygen is 12. So the equation is totally balanced. Okay. So while comparing these two, so we have to bring them out. We have Fe2SO4O3 2 3BaSO4. Now I gave us the difficult part of the element with their relative molecular mass are given or are to be known. So we have barium to be 137. The relative molecular mass of barium is 137. For iron is 56. For zinc is 65. For sulfur is 32. For oxygen it is 16. Yeah, that's all for this question. So let's compare this. So remember the first question we solved, we made use of the moles. We have the mole here is 1, the mole here is 3. We made use of the moles. Now why do we use moles to solve instead of to find the molecular mass of this compound? Now, if they are asking us for mole to mole relationship question, now this is a mass to mass relationship question. So they said, how many grams of this gram is mass? How many grams of this can be made when 42 grams? So it is a gram to gram relationship, a gram to gram problem. Now the first question we did was a mole to mole problem. So we had to use the mole of each compound to solve. But now they are asking us for the mass, so we have to find the molar mass of this whole compound to solve this question in order to get the mass of the one required and the one needed. Okay, so now we have 1 mole here, 1 mole of this compound. Let's find the relative molecular mass of this compound. We have Fe to be how many? 56, but we have Fe2, so I'm multiplying 56 by 2. So 56 times 2. So in this bracket means bracket 3 means this 3 multiplying everything in here. So we have plus 3 into, so that's 3 multiplying it. So sulfur is SO4, so sulfur is 1 here. So the molar mass of sulfur is 32. So we have 32 plus oxygen is 4. We have 16 times 4. 16 times 4 is 64, so we have 64. So if we add this 56 times 2 will give us 112 plus 3 into 16, 64. So 32 times 64 will give us 96. So we have 96. So let's add this, let's multiply this. 96 times 3, 96 times 3 will give us to be 400. So we have here 400 of this compound. The relative molecular mass of this compound is 400. The molar mass of the compound is 400. Now let's calculate for this. So this 3 means it is multiplying everything here. So therefore, let's calculate for this one. So we have 3 into barium. Barium was given as 137. So 137 plus sulfur is 32 plus oxygen is 16. 16 times 4 will give us 64. 64. So if we add everything, multiplying everything here by 3, so you give us 699 approximately. So this is it. So actually why here was 400 is because the mole of this compound is 1, so 400 times 1 will give us 1. But here the mole of this compound is 3, so anything you have, you multiply it by 3, that's what we have. So we have it to be 699. Now they said how many grams of barium sulfate. So where's barium sulfate? We have it to be here. Barium sulfate is X. How many grams? So they gave us how many grams of barium sulfate can be made when 42 grams of this, 42 grams of this. So we have to be 42. So let's solve. To multiply, we have 400. The up multiply the bottom. So we have 400 times X is equal to 42 times 699. So let's go side by 400 to make X with the formula because we're looking for X. So we have X to be 73.4 approximately. An approximate value 73.4 grams. So 73.4 grams can be made when 42 grams of this compound is used in a balanced chemical reaction. Now let's go for question 2. Question 2 is quite cheap but bulky. Alright, so now they said calculate the mass of zinc sulfate produced when excess NaCO3 is added to 500 cm cube of 0.40 dm cube mole per dm cube of H2SO4. Now this is the equation of the reaction to this question. First of all, let's check this. This is 500 cm cube. So remember I told you our volume should always be kept in dm cube. So what do? Divide it by 1000. So we get it in 0.5 dm cube. So now this is actually 0.5 dm cube. So now just to calculate the mass. So now we are dealing on mass to mass relationship. Okay, so calculating mass of ZnSO4. So we are talking about this compound produced when excess this is added to 500 this of H2SO4. So we are comparing ZnSO4 to H2SO4. So now let's go. So we have H2SO4 to ZnSO4. Now you look at comparing. So how many moles we have here? We have 1 mole. Okay, so note this that if we ask to find the mole of the compound, we are not to use the mole to solve. We are to use the molar mass of the compounds to solve. Now remember the first question I solved, they asked us to find the mole. So we actually use the moles of the compound to solve. Then we let's assume the mole given was 2.5. then we gave us x. So we are using the mole. So multiply, we got the value to be this. So now this part we have to find the mass. So when solving question that requires mass, we have to find the relative molecular mass of the compound. Okay, so now let's find the relative molecular mass of H2SO4. So for H2SO4, we have hydrogen to be 1 times 2 is 2, so we have 2, so 1 times 2 plus sulfur is 32 plus oxygen is 16 times 4, so we have it to be 64. So 16 times 4, 64. So we add this 2, 1 times 2 gives us 2 plus 32 plus 64. So if we add everything here, we add up, we have a value of 98 grams per mole. And that's for H2SO4. Now for ZnSO4, let's find it. So we have zinc. Zinc is 65 plus sulfur is 32 plus 16 times 4. So we have it to be this plus this will give us an approximate value to be 161 gram per mole. So now this is the mass, the molar mass of each compound. For H2O, for H2SO4, we have it to be 98. So that of ZnSO4 gave us 161. So 161 times 1, because it was 1 mole. The equation is actually balanced, you check, because if we have zinc here to be 1, zinc here 1. Carbon here 1, carbon here is 1 as well. Oxygen here is 3 plus oxygen here 4, so 7 oxygen on the right hand side. And oxygen is 4 plus 1 here plus 2 here, so we have to be 7 as well. So sulfur is 1, so the equation is actually balanced. Hydrogen here is 2, hydrogen here is 2, so the equation is balanced. So now each compound here are having 1 mole. So 1 mole times 98 equals 98, doesn't change. 1 mole of this times 161 gives us 161 without any change. Okay, so now you ask me to defend the mass of ZnSO4. So the mass of this is unknown. So what would be the mass? Look at this question. The mass of H2SO4 was not given, but what were we given? The volume and the concentration. So now how do we use volume and concentration to solve for mass? Now recall that I told you that mole is equal to concentration times volume. I use M in the beginning of the class. I use M times V, MV. So any of them you choose, they are all concentration. So now to find the mole, mole will be concentration. What the concentration given? 0.40. So 0.40 times the volume. The volume is 500 cm3. So I did some conversion up here before to be 0.5 because it was 500 over 1000. Meaning since it is cm3, combined to dm3, will give us 500 divided by 1000. So let's cancel out. 20 go 20, 5 here 1, 5 into 10 is 2. 2 here 1, 2 into 0.40 is 0.20. So our mole is equal to 0.2. So now that's the mole. Now remember we are dealing on mass and not mole. So let's convert our mole to mass. Now recall that I told you that the first formula given, our mole is equal to mass over molar mass. Mass over molar mass. So how do we find the mass? Because multiply. So therefore, this time this will be equal to this. So we have mole times molar mass will be equal to the mass of the compound. So now what's the mole of H2SO4? 0.2 times the molar mass. What the molar mass of H2SO4? 98. Use what we got here. So 98 times 0.2 give us 19.6 grams. So that's the mass of H2SO4. Now, meaning this whole thing here is trying to say it is 19.6 grams. So now, on stoichiometry, they actually use questions or parameters to confuse you on getting to know your understanding on that stoichiometry. So now, this type of question, they won't give you the mass of H2SO4 directly. They will give you other parameters for you to find the mass all by yourself, depending on the number of formulas you store in your head. So, using all the formulas I gave, we got to this point, finding the mass to be 19.6 grams. So now, our mass was of H2SO4 was 19.6. So, let's relate it. So, multiply, we have. So the third multiply at the bottom, we have 98 times x will be equal to 19.6 times 161. So divide those 7 98. So we have x will be equal to 32.2 approximately, 22.2 grams approximately. Now this is the answer to this question. So the mass of ZnSO4 produced is 32.2 grams. Okay, so now if you have viewed this video from the beginning of the class down to this point, I believe you will have no issue on that stoichiometry. But if you have any question that is giving you problem, you can drop the question on the comment section. Then justice will be done to the question immediately. Alright, if you are not following our page, please subscribe. Then drop any comment you have for our video. Thank you for watching.